Hi all, have a good day. I'm K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So the next topic in this lecture series is adjacent channel interference. So you know that there are two types of interferences, co-channel and adjacent channel interference. So already we have seen co-channel interference, which is caused because of co-channel cells, which are the cells that uses the same frequency. So next we'll see about adjacent channel interference. So adjacent channel interference is the interference caused to the signal which is adjacent in frequency to the desired signal. Imperfect receiver side filters allow the neighboring signal to mix with the actual pass band. If adjacent channel signal strength becomes strong, it will be difficult for base station to differentiate the actual mobile signal from the strong mobile signal. So the reason behind the adjacent channel interference is due to multiple channels close to each other communicating using similar frequencies. This is one reason, and the other reason is irrelevant power emission from an adjacent channels. So these two reasons are the reasons for adjacent channel interference. So next we will see the factors which is used for reducing the adjacent channel interference. The first one is we can use proper filters so that the filtering is proper, which can minimize the interference. Next one is careful channel assignments can be done. So that meaning is while allocating the channels, we have to allocate properly that the adjacent frequencies are not allocated to the adjacent cells. And next one is by managing the space between the two adjacent cells, which should remain a constant. That's the maximum. You can give a better spacing between the adjacent frequencies. The problem is severe if the user of adjacent channel is in close proximity, which is known as near-far effect. The other transmitter captures the receiver of the subscriber. Also, when a mobile station close to the base station transmits on a channel close to one being used by a weaker mobile. So this is the case one. So here the mobile receiver is captured by an unintended transmitter instead of the desired base station. So if you see here, so this is the unintended transmitter. So this is the actual transmitter. So the receiver, instead of receiving the signal from the required transmitter, it receives the signal from the unintended transmitter. The reason is the actual transmitter signal is very weak, and this signal from the unintended transmitter is stronger when compared to this weak signal. So the stronger signals are accepted than the weak signal. So this is case 2 where the base station faces difficulty in recognizing the actual uh, signal. So here if you see, so this is the base station, which is the actual receiver. This is the desired mobile transmitter, and this is a mobile which is an adjacent transmitter. Okay, so you are getting signals from both the adjacent mobile and transmitter and the desired mobile transmitter. So this signal is weak when compared to this signal. So the base station, what it will do is it will recognize this stronger signal than this weaker signal. So instead of receiving the actual signal, it will receive another signal which is not the original signal. So in order to minimize the adjacent channel interference, mainly we can do these two strategies. The first one is careful filtering. where minimum leakage or sharp transitions can be obtained. And the second one is better channel assignment strategy. So channels in a cell need not be adjacent. For channels within a cell, keep frequency separation as large as possible. So sequentially assigning the cells, the successive frequency channels can be avoided with adjacent cells. We can maintain a certain distance between the cells. Also, secondary level of interference can be reduced by not assigning adjacent channels to the neighboring cells. For a tolerable adjacent channel interference, we either need to increase the frequency separation or we need to reduce the passband bandwidth. Next one is power control for reducing the interference. Ensure each mobile transmits the smallest power necessary to maintain a good quality link on the reverse channel. So when the transmitting power is less, definitely the interference will get reduced. So when transmitting power is more, it will radiate to a larger distance, which will cause interference with the adjacent cells. So we have to maintain only less transmitting power. So it also leads to long battery life, which will increase the signal to interference ratio, and also it will solve the near far problem. So that's all about adjacent channel interference. So hope you understood clearly what is co-channel interference and what is adjacent channel interference. So in order to reduce both the interferences, the main thing is we have to maintain a minimum distance between the co-channel cells or the adjacent channel cells in order to avoid interference. So let us take some assessment questions. Adjacent channel interference occurs due to the options are A. Power transmitted by the base station, B. MSC, which is nothing but mobile switching center, C. Same frequency of mobile users, and D. Imperfect receiver users. Yes, the answer is imperfect receiver filters. These imperfect filters causes adjacent channel interference. Next one is which of the following problem occur due to adjacent channel interference? A. Blocked calls, B. Crosstalk, C. Near far effect, and D. Missed calls. Yes, here the answer is near far effect. Crosstalk, blocked calls, missed calls, all these will come under co-channel interference. Okay, so the voice calls will cause crosstalk and blocked calls and missed calls are due to channel control channel problems. Next one is in near far effect, a nearby transmitter captures the receiver. Options are A. Receiver of the subscriber, B. Transmitter of the subscriber, C. Nearby MSC, and D. Neighboring base station. Yes, the answer is receiver of the subscriber. Thank you for watching this video.